As you can see behind me, this site is rapidly taking shape. The cranes are working 24/7 to meet the ambitious targets set for the new city.
Behind me, hundreds of excavators are stripping away the desert surface to reveal the subterranean spine. The process begins with satellite LiDAR scanning to establish an absolute straight axis, with no more than 1 millimeter of deviation over 170 kilometers. British geodetic engineers are driving the first positioning markers using high-precision laser total stations. The surface sand is removed, exposing the sedimentary bedrock that must be processed with diamond-tipped drills. Hydraulic excavators begin lowering the ground level to 30 meters below sea level. This is the open trench phase, the optimal method for controlling the massive scale of the project. Engineers are checking the stability of the soil walls to prevent sand landslides. A diaphragm wall system made of reinforced concrete is being poured directly into the ground. Look at these steel cages. They are the load-bearing skeleton for the entire underground system. High-grade concrete mixers pour 24/7 to ensure seamless bonding without weak joints. After the diaphragm walls dry, excavators continue removing the earth in the middle to create a 1.5-meter-wide corridor. Geological engineers take soil samples every 50 meters to ensure there are no mud pockets or underground caves. Ground anchors are drilled deep into the rock walls on both sides to secure the wall structure. A layer of blinding concrete is poured at the bottom of the trench to create an absolute flat surface for the tube placement. You are now observing the British engineering team checking the flatness of the blinding concrete using ultrasonic sensors. This meticulous preparation of the trench floor is the prerequisite for the Maglev pod to run without vibration at 500 kilometers per hour. An underground drainage system is installed beneath the base concrete to prevent rising groundwater pressure. Massive steel I-beams are lowered to serve as temporary lateral bracing for the trench walls. Every movement of the machinery is monitored by a GPS RTK positioning system with micro-level precision. Notice the temporary solar panels providing power to the on-site monitoring stations. The chief engineers are meeting over digital blueprints to finalize the first tube lowering procedure. Super heavy transport trucks begin entering the site, carrying the alloy tube modules. Each 1-2-meter tube segment is wrapped in a protective layer to prevent scratches during transport. A 500-ton tower crane starts moving into position, ready for the core installation process. Engineers perform a final check of the trench floor's cleanliness before lowering the tube. Dust is the ultimate enemy of the magnetic levitation system, so a strict cleaning protocol is mandatory. Industrial LED lighting systems are illuminated along the newly excavated tunnel corridor. Engineers wear gas detectors to ensure oxygen safety in the deep subterranean environment. You will see the seamless coordination between the crane operator and the signal engineer in the trench. The first tube module is lowered into the trench, a moment requiring absolute silence and focus from the entire crew. The nose of the module is docked into high-precision joints precast into the concrete pedestals at the trench floor. Engineers use laser receivers to confirm that the module is positioned exactly on the global coordinate axis. Special high-density rubber pads are placed between the tube and the support to eliminate any potential seismic vibrations. We have completed the installation of the first module, the fundamental building block of the NEOM subterranean spine. Now we face the greatest challenge, transforming these hollow steel tubes into a high-speed propulsion system. This is electron beam welding, a technology normally reserved for rocket engines, used here to ensure airtight seals. British engineers monitor the weld temperature in real time through long-range infrared thermal cameras. Over 1 million kilometers of superconducting copper wire are being woven into the inner walls to create magnetic thrust. This is a smart electromagnetic grid, activating only where the pod is located to optimize energy efficiency. On the floor of the tube, neodymium permanent magnets are secured using specialized titanium alloy brackets. A 1 millimeter deviation in the magnetic track could result in catastrophe at speeds of 500 kilometers per hour. Magnetic levitation will lift the pod 10 centimeters high, completely eliminating surface friction for the first time. Fiber optic sensor networks are laid throughout the 170-kilometer route to detect even the slightest seismic vibrations. The combination of high-grade steel, copper, and artificial intelligence is creating a new mechanical marvel. Each vacuum pump station has enough power to evacuate the air from a 50-story building in less than 10 minutes. The chief engineer is now inspecting the high-pressure rubber seal systems at the maintenance hatches. These are potential dead points for leaks. Every door is protected by 3 independent locking layers. You are seeing British engineers using helium gas to search for leaks, the strictest inspection protocol in the world. Helium is the smallest molecule. If it cannot pass through, then air cannot enter either. Massive vacuum turbines begin to spin, pulling the internal pressure down to near absolute zero. The silence inside the tube now is a testament to the success of the laser welding and sealing process. A central AI computer analyzes 1 million data points per second to adjust the magnetic force in real time. The core manufacturing phase is now complete, ready for the first pods to enter for testing. Every component here is encoded with a QR code for permanent life cycle maintenance tracking. Heavy blast doors close, sealing the 170-kilometer spine into a single, controlled vacuum environment. Liquid cooling systems run alongside the tube to protect the coils from extreme heat during pod acceleration. Engineers wear gas detectors to ensure safety in these deep subterranean environments during final inspections. We are not just building a transport tube, we are redefining how humanity moves across the planet.
The glowing tracks behind me are energized and ready for the first run. This technology will revolutionize how we move through the city.
The KNTUPOD is a masterpiece of carbon fiber engineering designed to withstand the crushing pressure of the atmosphere outside. It now enters the pressure lock chamber, the only gateway between our world and the absolute vacuum of the spine. British specialists perform a final sensor handshake, ensuring the pod's internal AI is perfectly synced with the tunnel's grid. As the airlock seals, the environment becomes a void, eliminating the aerodynamic drag that has limited human speed for centuries. You are witnessing the first alignment where magnetic fins meet the stator coils with 0 mm tolerance. In the control center, every heartbeat of the machine is monitored. A single anomaly could abort the entire $175 billion mission. The sequence is initiated. We are about to wake up the largest linear motor ever built by man. Power surges through the copper veins of the tube, creating a magnetic wave that will carry the pod across the desert. Levitation achieved. The pod is now floating, untethered from the earth, supported only by the invisible hands of electromagnetism. The hum you hear is the sound of pure kinetic potential, the vibration of a future that is finally arriving. Acceleration begins. Within seconds, the pod will reach speeds that would tear a conventional aircraft apart at this altitude. 100 kilometers per hour. This is just the warm-up for a system designed to exceed the speed of sound in a tube. Even in a vacuum, the friction of remaining molecules creates intense heat, tested by our advanced thermal shielding. This is the make-or-break moment for the British team, confirming that the theory is now a reality on the desert floor. Test Section 1 complete. The pod has successfully demonstrated that the spine is alive and ready for the 170-kilometer sprint. At the heart of the spine is the NEOM Command Center, where an AI-driven digital twin monitors every millimeter of the 170-kilometer route. This central brain coordinates 9 million journeys daily, ensuring that no pod is ever more than a few milliseconds away from its destination. Logistics here are invisible. A fleet of autonomous cargo pods moves goods through a dedicated subterranean layer at high velocity. In the sorting hubs, robotic arms with sub-millimeter precision handle everything from heavy machinery parts to daily groceries. British software engineers manage the Spine OS, a massive neural network that predicts traffic surges before they even happen. We are witnessing a three-dimensional logistics grid where tubes cross at multiple levels without a single traffic light. Fiber optic sensor networks act as the city's nervous system, reporting the pod's exact position and health every microsecond. AI algorithms automatically adjust pod intervals, maintaining a safety buffer that is physically impossible for human drivers to achieve. Maintenance is proactive. Autonomous service vehicles patrol the side tracks 24/7, repairing systems without ever stopping the main flow. Supply chains are now compressed into minutes, as cargo pods deliver essential medical supplies across the desert in record time. Thousands of high-speed sensors and cameras ensure that the vacuum environment remains secure and the propulsion system stable. Every pod journey is a mathematical optimization problem solved in real time by the world's most advanced logistics AI. The speed of commerce in the line is no longer limited by roads, but by the raw processing power of the spine's servers. Energy is recycled. The system captures the braking energy of incoming pods to power those accelerating elsewhere.
Behind me is the heart of the operation. This new facility houses over 500 racks, processing transactions around the clock.
In the world's most extreme safety labs, we push every component of the spine to its absolute breaking point. Engineers monitor structural stress in real time, ensuring that a pod can withstand forces 10 times greater than any operational scenario. Ballistic impact tests confirm the carbon fiber hull can protect passengers even in the event of a high-speed debris collision. In case of fire, the vacuum is replaced by an inert nitrogen mist, suffocating any flame in milliseconds without damaging the electronics. Our magnetic emergency brakes can stop a multi-ton pod from 500 kilometers per hour in less than a kilometer. Rapid repair robots are stationed every 5 kilometers, capable of sealing a hull breach before the internal pressure drops to dangerous levels. Every section of the spine features a fully autonomous life support shelter, capable of sustaining passengers for 72 hours. Advanced seismic dampers allow the 170-kilometer tube to flex and absorb a magnitude 9 earthquake without cracking. Human drills are relentless. Our British teams practice emergency evacuations in total darkness to ensure zero-error coordination. The system's safety AI is triple redundant, mirrored across 3 separate underground server locations to prevent any single point of failure. Decompression tests simulate the worst-case scenario, a total seal failure in the desert heat, forcing the thermal systems to compensate. We don't just plan for success, we engineer for every possible failure, building a network that is fundamentally uncrashable. Mechanical flywheels provide instant backup power, ensuring that even in a total grid blackout, the pods never lose levitation. Autonomous rescue drones act as the first responders, reaching any incident point in the tunnel within 60 seconds.
The blast doors are sealing. Once they close, there is no way out. We have failed to contain the situation.
This is the Golden Connection, the final 12-meter segment that will bridge the gap between the east and west sections of the spine. There is no room for error. The $200 billion structure now relies on a tolerance of less than 0.5 millimeters. Our British engineering leads have spent 5 years preparing for this single day, the culmination of a decade of planning. The final 360 weld begins, sealing the vacuum environment of the entire city-scale project for the first time. With the tunnel sealed, the last module of the magnetic track is locked into place, completing the world's longest linear motor. Every titanium bolt is torqued to precise specifications, ensuring the structure can survive the immense kinetic energy of a flying pod. The digital nervous system is connected. A single data pulse confirms that the 170-kilometer network is now fully sentient. Vacuum pumps reach maximum capacity, pulling the internal pressure down to the equivalent of the edge of space. The void is now perfect, 170 kilometers of absolute stillness, waiting for the first wave of energy. Master activation sequence initiated. The Spine OS is now in control of the largest transport engine in human history. From the Red Sea to the desert mountains, the status lights turn green. The line is officially open for transit. The electromagnetic field wakes up, lifting the first pod with the power of 1,000 jet engines, yet without a single sound. 510 kilometers per hour. We have just turned the world's most ambitious drawing into the world's fastest reality. This moment marks the end of the construction era and the beginning of a new way of life for 9 million people.
And there you have it, the Maglev Innovation Path Pod completing its historic run. A new era of transit begins today.
What was once a line drawn in the sand is now the most advanced infrastructure on the planet, a 170-kilometer testament to human will. The spine is no longer just an engineering project, it is the pulse of a new civilization, moving people and goods at the speed of thought. Behind every kilometer are the hands of thousands of engineers who refuse to believe that impossible was a final answer. With a system that is 100% operational, The desert is no longer a barrier, but a canvas for the future of mobility. The line stands as a mirror to our own potential, a structure that respects the Earth while elevating the spirit of innovation. Our British teams and global partners have built more than a tunnel. They have built a legacy that will be studied for centuries. The invisible force of the Maglev is the new gravity of commerce, a silent power that defines the modern era. Lara, from ground zero to the finish line, we have decoded the DNA of the impossible. The spine is ready. The future is here. This is the triumph of precision over chaos, of engineering over nature, and of vision over the vastness of the desert. If you are ready to witness more mega projects that defy the limits of physics, subscribe and join us on our next journey into the impossible.